Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig. And this podcast is all about AWS. And here we share our insights in our day-to-day work, where we basically spend all our time working on the AWS platform. This is episode number 72, and we are recording this on March the 9th in 2023. In case you're watching this live on YouTube, feel free to ask your questions in the chat. Besides that, you can reach us on LinkedIn, on Mastodon, or you can also send us an email with your questions and then we can answer them in the next show. So, Andreas, what are you working on this week?
So I've been, besides many things, I've been working on the Marburg documentation, and maybe one thing to mention here is I've been working on fixing some bugs in the AWS debug games. So in case you are interested in going through challenges and solving tricky AWS issues, check out games.cloudonaut.io, which is where you can find those debug games and start them in your own AWS account. There are always some tricky challenges to solve in the infrastructure that we deploy into your account, and you learn a lot by doing so. So go check that out.
Okay, great, Andreas. So I was working on, most of my time I was working on our S3 antivirus solution, BucketAV. So we are working on something big there, not yet public announced, but it will take, I think, a couple of more days or weeks to get it done. So this is still something that I am working on at the moment. So yeah, besides that, Andreas, let's go into what we learned last week using AWS. So you might have something for us, right?
Yeah. So actually, I learned something by reading through my Mastodon feed. Because I saw Luke, he measured the latencies for different event-driven architectures and has written about that multiple times. And I will put a link to his article into the show notes and video description. It's basically measuring the serverless messaging latency of different services. So, for example, EventBridge or SNS and so on. And I think what's quite interesting is that this latency from those messaging services to calling a Lambda function is actually quite different from. So, for example, SQS standard has a latency, a P99 latency of 100 milliseconds. DynamoDB streams have 500 milliseconds. EventBridge, for example, is somewhere in between. And what Luke found out is that the latency of the EventBridge that he was measuring, it has dropped by 50% in February. And he was talking about that, and I found that interesting. And the whole thing about measuring those latencies and stuff brought me to a question, which is, shouldn't there be an SLA for the latency that we can expect from all those messaging services? Because as we do, for example, we use Kinesis, and it's actually quite important to rely on a certain latency, because in our case, Marburg, the chatbot, is basically not really usable if the latency increases. So the question is, if you're now measuring the latencies of all those services like SNS, Kinesis, and so on, and you build your architecture based on that, and then next month, for some reason, the latency doubles or something, we don't really have any commitment from AWS that this is the latency that they are trying to achieve. It could, for example, with Luke's measurements, it could be that he was just measuring an improvement that AWS is planning to later on basically eat by deploying a new feature that will then worsen the latency or something like that. So actually, I think as we rely on those latency when architecting with those messaging services, we should have some way to consider what the target latency is that AWS is working with. So I found this quite interesting, and I think that's something that AWS should publish somewhere.
Yeah, and one thing to add, Andreas, just to make this very clear, because I was confused about that. So what is the latency that was actually measured? And this is really the time that is added, like from the moment where you produce the message until it is consumed on the other end. So it's kind of the whole like processing time of the message basically in the event system. So it's not just the latency to submit the message or something like that. Because that was my, like when I first read that, that was my impression. But it's really like the whole kind of processing time or however you want to call that.
Yeah, and when you add something like that into your architecture, that's the important aspect basically. So in some cases, in others it's not, but you better know.
I mean, there are, I think, many factors that would, I mean, the numbers that are measured, I think it's interesting, but as you said, it's not something that's guaranteed. So what I find interesting, and this all matches with our experience, is that Kinesis data streams is on the, I would say, on the slow side. It's one of the slowest, I think it's the slowest actually system that was measured. And we noticed that as well because we use Kinesis data stream in Marbot. So whenever you type a command or like whenever you type text in Slack and then you send it to the Marbot bot, basically what happens behind the scenes is at some point in time it is pushed on our Kinesis stream. And then we switch to the enhanced fan out, and this really improves the latency dramatically. And this is also kind of what was measured here by Luke, because it's really more than like a 15-time reduction in latency, for example, for Kinesis. So that's interesting. I mean, you pay basically twice the price for it, but it for us it was important. So that's why we enabled it, for example. So this was just one thing that catched my attention. Besides that, I'm always interested in such numbers. I don't know if it was measured in a specific region actually. At least it's not.
I don't know.
Oh, it's measured in Ireland. Okay, so I see that. Yeah. So that might also be interesting to measure it in other regions because we know that at least the rate limits are very different. For example,
SNS,
in smaller regions, could be much different in a small region.
Yeah, that's right. Okay. Yeah. So be careful, and AWS, think about releasing some of your numbers here. That helps a lot when architecting on those things. Yeah. Okay, Michael. Next.
Yeah. Great. All right. So I was actually also kind of, I mean, it's not not the same, but similar kind of topic. I was working on, and this is like comes out of our Marbot product, where we basically try to monitor your AWS resources, and this includes EC2 instances. And this means that we deploy a CloudWatch alarm for you for every EC2 instance that is enabled, that is running, sorry. And the problem is that, I mean, because we have no understanding of the workload in terms of we don't know if this is a batch system or if this is like a server that runs 24/7 and receives traffic and over time the utilization changes. So we don't know that. But we know from customers that they have batch jobs that can cause periodic spikes, and they are very okay with that spike. So that was kind of the feedback that we received. So we had customers that, and this was in this case, backup jobs usually. So once a day and then this could be 30 minutes or depending on the size of the backup, their CPU utilization was much higher than compared to other periods, and compared to other times of the day. And what I also bring to the table is that I don't think that the CPU utilization below 80% is a problem at all. Like if you have a server running and this is 70% utilized, this should never be an issue because I mean that's what it's made for, right? I mean it has a CPU, so it can do something for us. Besides that, it just spins and is idling. So that's not a big deal as well. So what I thought could solve our issue, and what also like some experiments showed, is that we could turn on anomaly detection. And this is a feature of CloudWatch that basically learns the pattern of your metric, and it understands, for example, that once a day there is a spike, and then it basically, the threshold is then kind of adjusted over time based on what the model learned from the past data. So this worked perfectly for the use case where the customer had like I think they had around 60-70% utilization, and then once a day it went off to 90% or something. So this worked for them out of the box, no problem. But on the other side, we also have customers that have idle instances. So they run at 1% utilization. And basically for all the time. I mean, you could argue that they probably could turn that machine off or size it down or something, but that's not our discussion. So the instance is more or less 1% utilized all the time. But then, and now, Andreas, pay attention, it jumps to 7% utilization. So it goes from 1 to 7. I mean, that's a really big deal, right? And at least for anomaly detection, that's a big deal. They immediately flag that as an issue, like an outlier.
Yeah, it's an outlier.
But, I mean, an instance running at 7% utilization is not a big deal, right? I mean, it's still 7%. That's not going to hurt anyone. So the question was, how can I kind of balance those two scenarios? And what I did is I used metric math to kind of modify the input that goes into the model. And basically what I use is if, the function is called if, and you can say if your metric is below, in my case 80, then the value should be 80, otherwise use the value from the time series. And so basically how the graph now changes. The CPU utilization that goes into the anomaly detection model is always 80 or higher. So in this case, the 7% or 1 to 7% jump is not visible to the model because it's always 80. And with this change, we actually have been able to kind of solve the problem. There's one side note, Andreas. One thing that we also learned is that there is a limit of the number of anomaly detection models in a region, and this is 500. And it's not so easy to change that. So it's not a quota. You can open a support request and then ask them to kind of manually fiddle around with this limit and increase it, but there's no way to increase it in an automated way. So keep that in mind if you have many EC2 instances, then you could run into this limit. That's it. That was a little bit longer than I expected. Sorry for that. So Andreas, do you have anything else on your list?
Yeah. So I've been, so we have migrated a lot of legacy web applications to AWS over the years. They're very popular CMS systems like WordPress. In Germany, there's Typo3 and others. And all those PHP legacy web applications typically have the challenge that it's not that easy to run them on multiple machines in parallel. So that you can achieve high availability and be able to do rolling updates and stuff like that. And what we often do, so we have CloudFormation templates to spin up WordPress, and I've been doing that with consulting clients a lot. We typically use EFS to synchronize the file system between the machines. And I've been doing so multiple times, and it kind of works. The problem is always that, especially with PHP applications, which basically parses the PHP files to answer incoming requests, that the number of files that need to get parsed because of the modularization and libraries that such an application uses. So I think it's fair to say that it loads probably something like tens or hundreds of files to answer a single request. And you can then fiddle around and cache those files in memory and stuff like that. And then you have the problem that those things are stale and when you do an update of the application and stuff like that. So, and if you don't have the PHP files on EFS, then it's harder to use the automated updates that most of those systems come with and stuff like that. So yeah, so the lesson that I've learned over the past years is it's possible to run legacy web applications, for example, PHP stuff on EFS. So to also have the PHP files stored on EFS, not only user uploads and stuff. But the problem is you can tune it and cache things, but you are always running into issues. You either have stale files and then things go wrong, or loading the whole thing, so loading a page and loading all those files takes seconds and not milliseconds to show a page. So what I've been doing over the past few months is I have basically rebuilt all those architectures where we had used EFS as the distributed file system and run the workload on multiple machines. I have re-architected all those things and now run it on a single EC2 instance. Have some CloudWatch metrics in place that automatically try to replace the failed instance, and have a dedicated EBS volume for everything application related and back that up separately so that I can switch the EC2 machine when I have a new AMI and stuff. So I don't have high availability in multiple availability zones anymore. I can update the AMI without terminating the instance and causing a short downtime. But on the other hand, the legacy application has, so I don't have any performance or stale data issues anymore. And I think in most cases, it's not worth the effort to try to get those legacy web applications running in a distributed fashion with EFS as the file system. So that's what I've learned over the years.
Yeah. And I think what's interesting is that this still applies, right? Because I mean, there was a change to EFS. I think it was maybe a year ago, so that they mentioned that they improved performance for small files and stuff, and it also the performance improved. But what you say is that it still is too slow to run a. Yeah. And I mean, I think the PHP projects that you mentioned, I mean, those are like, is it like Typo 3 and stuff like this, like so large PHP applications,
all that stuff, yeah,
WordPress stuff, yeah. So where you have little control over what's actually going on with all those plugins and stuff and auto updates, as you mentioned. So it's always a challenge to run those things on a like a more modern architecture.
And the other problem is you have often in those scenarios, you have developers who need access to those machines and they want to copy their files, their stuff like that. They work in a very, so in the old-fashioned way, I would say. So that's the reason why you can't just have those files deliver that in a static way. So that would be the other option. So I've played around with, for example, bundling those PHP applications in containers. So there's ways to do that with WordPress. There's where you basically define all the plugins that you need and the versions, and then it just fetches everything, bundles that together. This is for Typo 3 as well, and others probably also. But then you have a totally other way of working, and this is in the scenarios that I've worked in, was the issue that then the developers can no longer use auto update of the system, install their plugins by uploading things, and that is then the challenge. I think that's another option to get those things running on AWS.
Yeah, I see. All right, Andreas. So I have one little tip, and this is something that I learned and I really like it. And this is for everyone that uses the Amazon Linux 2 Docker image. And I'm using that a lot. So the Docker image itself is very slim. So I mean, there are definitely smaller ones, but it's I think 30 max or something like that. So basically it misses a lot of tools that you usually kind of find on an EC2 instance. And sometimes I just want to have like a kind of an EC2 instance locally running on my machine to test something out. So, and what I always end up is I have to install telnet, yum install, zip yum or unzip yum install, all kinds of basic kind of utilities that I usually need. And it turns out there's a nice way to install everything that has to be, or that is on an AMI. And this is this command that I just posted into the chat. It's called yum group install AMI. And this actually installs all the packages that are installed on the AMI. And that's great. I mean, I think it installs over 100 packages, so it takes a little bit of time, but then you have like the same environment that you have in an AMI. And that was very helpful for me because I tried to install an application there and I tested my like startup script and things like that. And this is just an easy way to get everything in place that's available on the AMI as well. So that's the last thing that I want to share, Andreas. Do you have anything else on your list?
Yeah, so one more thing. So actually, Michael, that's great because I'm running into that problem that the container image is not the same as the EC2 machine. And then when I wanted to test things, it didn't work. I have one more thing. So I will later release a new blog post, and I wanted to share the insights here first. So I've written a blog post about monitoring AWS with event bridge rules. So typically when you think about monitoring AWS, probably the first service that comes to your mind is CloudWatch. So that's where we have all those metrics and logs and define alarms and stuff like that to monitor your workload. But I think it is quite interesting to also think about EventBridge as a way to get notified about all of kinds of things in your AWS account that can go wrong. And basically, what you need to do to set this up, it's quite easy. So all kinds of AWS services, in the same way that they send metrics to CloudWatch, they publish events to EventBridge. So about their state and the infrastructure state. And what you can do is you can create EventBridge rules to basically subscribe to those notifications, and then, for example, forward them to an SNS topic, and from there forward them to an email address, or what we prefer, use HTTPS and forward them to Marbot, our chatbot, to monitor things. And I've written a blog post with a few examples of what you can, and I think even should, monitor by creating EventBridge rules. And there are also code examples so in the blog post. So check that out later. We publish that later on cloudonaut.io. So a few things that you can monitor. So for example, you can monitor when someone uses the AWS account root user to log into your account. You can write an EventBridge rule for that. Or there's AWS Health, the health dashboard that shows things like outages and also planned changes to the infrastructure that might affect you, things like that. So I don't know, a planned release that might affect you. So it is important, to, in my opinion, to monitoring those AWS Health announcements as well, and that's also possible with EventBridge. Another thing that you can monitor with EventBridge is EC2 autoscaling, because it's possible that when an autoscaling group tries to launch an instance, it's not possible to do so. This could be because of a misconfiguration. It could be because of any issues, underlying issues in the infrastructure, and you want to know about that. And you can monitor those events from autoscaling with EventBridge as well. Or as we probably all do for backing up data, we're doing snapshots, EBS snapshots of volumes. Again, it's possible that those things fail because of misconfigurations and stuff like that. So you should get notified about those things, because usually you don't notice when things are happening just over the day. Another example is SSM automations. So if you use Systems Manager to automate management of your EC2 instances, you should definitely create EventBridge rules to monitor those things, so to get notified when automations fail or time out, stuff like that. So that's another example. Maybe three more things. So you can monitor the Amazon Certificate Manager with EventBridge as well to get notified when your certificate expire. You can use EventBridge to monitor AWS backup. So when backup jobs are failing, you can get notified about that. And for example, if you're using Elastic Beanstalk to deploy web applications, it's really easy to monitor changes of the health of your system with EventBridge as well. So in summary, I think when we think about monitoring AWS infrastructures, we should not only think about what are the metrics that I want to monitor, we should also think about which of the events sent over EventBridge are worth monitoring, and we should make sure that we are forwarding them somewhere where we notice them and can react accordingly. So multiple times in our AWS accounts, I've got notifications about things in the underlying infrastructure that were really, really important and critical to the availability of the application. So I think that is an underrated way to monitor your AWS infrastructure.
Yeah, I 100% agree with that, Andreas. So we are always kind of surprised what interesting messages come out of EventBridge when you look into our Slack channel that receives all that messages from Marbot. And I mean, as you said, you will release a blog post with all those rules
with code examples,
like in a copy and paste format, so you can just apply them.
Yeah.
Besides that, I mean, one thing to notice or to mention is that if you use Marbot creates all those EventBridge rules for you automatically. So no need to do that manually then. And I think we create more than, I'm not 100% sure, but I think it's more than 50 or even 70 rules.
Default, yeah.
So because of what you said, Andreas, there's a lot of interesting stuff published to EventBridge. This also includes LDS, like database notifications, Elasticsearch, Elastic Cache, like all the like the stateful services. Yeah. So cool, Andreas. That's it, I think.
Yeah. We will be back probably next week. Subscribe to our newsletter, podcast, or YouTube channel to make sure you're not missing the upcoming shows. And we're also looking forward to your feedback. So write into hello@cloudonaut.io or find us on LinkedIn or Mastodon.
Yeah, we also want to thank our supporters who make this show possible. And if you are like a fan of the show, consider supporting our work as well. So there are a couple of options available, one-time and recurring. You will find the details in the show notes as well. So thank you very much for listening and watching this. We will see us next time. Have a great day and bye.
Bye.